Welcome to episode 234 of CXO Talk. I'm Michael Krigsman, and CXO Talk brings you truly the most innovative people in the world talking about topics relating to digital disruption and machine learning and all kinds of good stuff. Before we begin, I want to say a hearty thank you to our live streaming video platform, which is Livestream. Those guys are great. And if you go to livestream.com/CXOTalk, they will even give you a discount. So today we are speaking with somebody who is a pioneer in the use of data and analytics in consumer real estate. And we're speaking with Stan Humphries, who is the Chief Analytics Officer and also the Chief Economist of the Zillow Group. And I think everybody knows the Zillow Group as Zillow and the Z Estimate. Stan Humphries, how are you?
Hey, Michael, how you doing? It's good to be with you today.
I am great. So, Stan, thanks for taking some time with us. And please tell us about the Zillow Group and tell us, what does a Chief Analytics Officer and Chief Economist do?
Yeah, you bet. So let's see. I've been with Zillow since pretty much the very beginning, back in 2005, when what became Zillow was just a glimmer in our eye. Back then, I worked a lot on just algorithm and some product development pieces, kind of a lot of the data pieces in the organization. We launched Zillow in February of 2006. And back then, I think people who are familiar with Zillow now may not remember that for our first couple of years between 2006 and 2008, all you could find on Zillow was really all the public record information about homes and displayed on a map, and then a Zestimate, which is an estimated home value in every single home, and then a bunch of housing indices and things to help people understand what was happening to prices in their local markets. But we really grew the portfolio of offerings to help consumers from there, and added in ultimately for sale listings, for rent listings, a mortgage marketplace, a home improvement marketplace, and then along the way also brought in other brands. So now Zillow Group includes not only Zillow brand itself, Zillow.com, but also Trulia, as well as StreetEasy in New York, Naked Apartments, which is a rental property, a rental website in New York, Hot Pads, and a few other brands as well. So it's really kind of grown over the years. And last month, all those brands combined got about 171 million unique users to them online. So it's been a lot of fun kind of seeing it evolve over the years.
So, Stan, how has so you started with the Zestimate. Well, you started aggregating data together, and then you came up with the Zestimate. What was the genesis of that Zestimate? And maybe you can explain what that is.
Yeah, sure. So we were, in the early days, we were looking at different concepts it seemed like there was a lot of interest in from consumers about real estate. And, I think there was a lot of angst about really what I think as an economist, we think of as information asymmetry. So the fact that certain participants in the marketplace of real estate had a lot of information and other people didn't have any information. And we felt, I think, in a lot of the leadership team that founded Zillow, our reference point was, we were, I guess, very passionate about more of this social progress of transparency in various marketplaces, which you had seen in the 80s and 90s in stock markets. We had been part of, actually prior to Zillow, at Expedia, about eliminating information asymmetries in the travel agency space. You had seen it in insurance and a lot of different sectors. We were very interested in kind of creating information transparency in the real estate sector. So that got us very interested in where was the information that people wanted, and how could we get it, and how could we make it available for free to consumers. And once we had done that, a lot of that information is squirreled away in county tax assessors or county recorders' offices around the country. And how our country is organized is those tend to be, more than 3,000 different counties around the country, and each office has a different format of a file. And it became our job to try to go out to all those different places and get all that data and put it online in a standardized way. And you asked about the Zestimate. The way that came about was once we had done that, and we would bring people in the early days, and we would show them a UI of what we were, a user interface of what we were trying to do, and we would show them these maps of recently sold homes, and then you could click on any house, and see the public facts and when it last sold. We noticed that people had what we thought was really a really focused interest on recently sold homes, and they would jot them down on napkins when we brought them into the offices to look at the user interface for focus groups. And we were like, what are you doing there? And it became clear that they were very interested in looking at recently sold homes in order to try to understand the value of a home that they might be looking to either buy or sell in the future. And that was kind of an aha moment where we thought, wow, okay, if you're trying to figure out an estimated price for a home, then maybe we can help you do that better than just napkin math. So that was the genesis of this estimate. And today we do a whole lot more than napkin math. It has become a very substantially computationally intense process to create this estimate.
How has the Zestimate changed since you began it?
Yeah. So back in if you look at when we first rolled out in 2006, the Zestimate was a valuation that we placed on every single home that we had in our database at that time, which was 43 million homes. And in order to create that valuation on 43 million homes, it ran about once a month, and we pushed a couple terabytes of data through about 34,000 statistical models, which we thought was compared to what had been done previously, was an enormously computationally more sophisticated process. But if you flash forward to today, well, and actually, I should just give you also a context of what our accuracy was back then. Back in 2006, when we launched, we were at about 14% median absolute percent error on 43 million homes. So what we've done since then is we have gone from 43 million homes to 110 million homes today, where we put valuations on all 110 million homes, and we've driven our accuracy down to about 5% today, which we think from a machine learning perspective is actually quite impressive, because those 43 million homes that we started with in 2006 um, tended to be in the largest metropolitan areas where there was a lot of transactional velocity. There were a lot of sales and price signals with which to train the models. What's in the rest of, as we went from 43 million to 110, you're now getting out into places like Idaho and Arkansas, where there are just fewer sales to look at. And it would have been impressive if we had kept our error rate at 14% while getting out to places that are harder to estimate. But not only did we more than double our coverage from 43 to 110 million homes, but we also almost tripled our accuracy rate from 14% down to 5. Now, the hidden story of how we were able to achieve that was basically by throwing enormously more data, collecting more data, and getting a lot more sophisticated algorithmically in what we were doing, which required us to use more computers. Just to give a context, I said that back when we launched, we built 34,000 statistical models every single month. Today, we update this estimate every single night. And in order to do that, we generate somewhere between 7 to 11 million statistical models every single night. And then when we're done with that process, we throw them away and we repeat it again the next night. So it is it's a big data problem.
How did your, shall we say, algorithmic thinking change and become more sophisticated from the time you began? What was the evolution of that? That must be very interesting.
Yeah, it certainly has been. There have been, there have been a few major uh, changes to the algorithm. We launched in 2006. We did a major change to the algorithm in 2008, another major change in 2011, and then we are now rolling out another major change. Right now, it started in December and will be fully deployed with that new algorithm in June. Now, that's not to say every single day in between those major releases, we are doing work and changing uh, bits and pieces of the framework. Those times I described there are kind of major changes to the overall kind of modeling approach. And what has changed is um, as is probably suggested by the fact of how many statistical and machine learning models are being generated right now in the process. What has changed a lot is the granularity at which these models are getting run, meaning a lot finer geographic granularity, and also the number of models that are being generated. So right now, when we launched, we were generally looking at um, a county, and in some cases, for very sparse data, maybe a state in order to generate a model. And there were, like I said, 34,000 of those different models. Today, we are generally looking at, we never go above a county level for the modeling system. And in large counties with a lot of transactions, we break that down into smaller regions within the county, where the algorithm is trying to find homogeneous sets of homes in a sub-county level in order to train a modeling framework. And that modeling framework itself contains an enormous amount of models, where there are models, basically the framework incorporates a bunch of different ways to think about values of homes combined with statistical classifiers. So maybe it's a decision tree, thinking about it from what's called hedonic, or a housing characteristics approach, or maybe it's a support vector machine looking at prior sale prices. Um, the combination of the valuation approach and the classifier together create a model, and there are a bunch of these models generated at that sub county geography. And then there are a bunch of models which we call meta models, which their job is to put together these sub models into a final consensus opinion, which is the Zestimate.
Uh, this is very it's very interesting, and I want to remind people that we're talking with Stan Humphreys, who is the chief analytics officer and also the chief economist at the Zillow Group. And I think most people probably know of the Zestimate that automatically estimates, presents a value for any piece of real estate. Stan, so you've been talking about your use of data and the development of these models, but real estate has been a data intensive business, right? I mean, all real estate, the MLS shares real estate data, but it's static data. And so, again, what were you doing, and how did this change the nature of the real estate market? So if you can go from now the technology into the disruptive business dimensions.
Sure. Yeah. I think, I mean, you're right, Michael, in the sense that, there's always been a lot of data floating around real estate. I would say, though, that a lot of that data had been largely untapped. And so it kind of had a lot of unrealized potential. And that's a that's a space that, as a data person, you love to find. And honestly, um, travel, which a lot of us were in before, was a similar space where it was just dripping with data, and a lot of people had not done very much with that data, and so it just meant that, really, a day wouldn't go by when you wouldn't come up with, holy crap, like, well, let's do this with the data. Um, and real estate was one where we certainly had multiple listing services had arisen for the very purpose of facilitating the exchange of real estate between unrelated brokers, um, and which was a very important purpose. But it was a system. There was multiple listing services, which were between different agents and brokers on the real estate side that were homes that were for sale. You had, though, a public record system, which was completely independent of that, and actually two public record systems: one about deeds and liens on real estate, on real property, and then another which was the tax rolls. And all of that was kind of disparate information. And the information that what we were trying to solve was the fact that all of this was offline, and we really just had the sense that it was like, from a consumer's perspective, it was like the Wizard of Oz, where it was, it was all behind this curtain, and you couldn't really look, you weren't allowed behind the curtain, and you really just wanted to know, well, I'd like to see all the sales myself and figure out what's going on. And you'd like a website to show you both the for sale listings and the for rent listings. But of course, the people who were selling you the homes didn't want you to see the rentals alongside them because maybe they, would like you to buy a home, not rent a home. And we were like, we just put, everything together, everything online. And, we had a faith that that type of transparency was going to benefit the consumer. And I think it has, where, what's been interesting in this evolution is that, you still find that agency representation is very important. And I think the reason that's been true is that it's a very expensive transaction. It will be generally for most Americans the most expensive transaction and the most expensive financial asset they will ever own. And so there has been, it continues to be a reliance, I think a reasonable reliance on an agent to help hold their hand for a consumer as they either buy or sell real estate. But what has changed is that now consumers have access to the same information that their representation has, either on the buy or sell side. And I think that's really enriched the dialogue and facilitated the agents and brokers who are helping these people. Where now a consumer comes to the agent with a lot more awareness and knowledge, and is a smarter consumer, and is really working with the agent as a partner, where they've got a lot of data and the the agent has a lot of insight and experience, and together, we think they make better decisions than they did before.
I want to tell everybody that there's a problem with Twitter at the moment, and so if you're trying to tweet about the show, and your tweet is not going through, try doing it a second time, and sometimes that seems to be making it
I'm
work.
I'm so glad to hear that you said it, Michael, because I just tried to retweet right before I got on, and I couldn't do it, and I thought it was my Twitter app. Sounds like it's Twitter overall.
Yes, it seems like we're back to the days of Twitter having some technical issues. Anyway, so Stan, in a way, through by the act of trying to increase this transparency across the broad real estate market, you need to be shall we say, a neutral observer. And so how do you ensure that in your models you're as free from bias as as you can be? And maybe would you also mind explaining the issue of bias a little bit, just briefly? I mean, we could spend an hour on this, but briefly. So what is the bias issue in machine learning that you have to face, and how do you address it in your situation?
Okay. Yeah, I may ask you for a few more sentences on the bias issue in machine learning because I, as a data person, I'm thinking about that from a statistical sense, but I'm guessing that's probably not how you mean it. But in terms of the business model itself and how we think and how that interacts with machine learning and what we're trying to do, we are our North Star for all of our brands is the consumer, full stop. So we want to surprise and delight and best service our consumers because we think that by doing that, that then, advertising dollars follow consumers is our belief, and that we want to help consumers so the best we can. And what we're trying to construct and have constructed is in an economic uh, language is a two-sided marketplace where we've got consumers coming in who want to access inventory and get in touch with professionals. And then on the other side of that marketplace, we've got professionals, be it real estate brokers or agents or mortgage lenders or home improvers who want to help those consumers do things. And what we're trying to do is provide a marketplace where consumers can find inventory and can find professionals to help them get things done. So from from the from the perspective of a market maker versus a market participant, you want to be completely neutral and unbiased in that, where you're not trying to, all you're trying to do is try to get a consumer to the right professional and vice versa. Um, and and we, that's very important to us. So that means that when it comes to like machine learning applications, for example, the valuations that we do, our intent is to try to come up with the 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 best estimate for what a home's going to sell for, which is, again, thinking about it from an economic perspective, it's different than the asking price or the offer price. that, in a commodities context, you call that a bid-ask spread between what someone's going to ask and a bid. In the real estate context, we call that the offer price and the asking the asking price. And so, you know, what someone's going to offer to sell you their house for is different than what a buyer's going to come in and say, well, hey, would you take this for it? There's always a gap between that. What we're trying to do with estimates is uh, to better inform some pricing decisions, such that bid ask spread is smaller, such that we don't have buyers who end up buying a home and getting taken advantage of when the home was worth a lot less, and we don't have sellers who end up selling a house for a lot less than they could have gotten because they just didn't know. So we think that they're having great competent representation on both sides is important, is one way to mitigate that, and one way that we think is fantastic. Having more information about pricing decisions to help you understand what that offered offer ask ratio, or what that offer ask spread looks like, is very important as well.
So, from a data collection standpoint and then a data analysis standpoint, how do you make sure that you are collecting the right data and then analyzing it in the right way so that you're not influenced wrongly, or over influenced in one direction or under influenced in another direction, which would of course lead to distortions in the price estimates?
Yeah. Let's see. I'm trying to think of biases that we watch for in the valuation process. I mean, one obvious one is that the valuation that we're trying to produce is a valuation of um, uh, a of a arm's length fair market exchange of a home. Which those words are important because it means that there are a lot of transactions which are not full value in arm's length. So, if you look in the public record and you start to build models off the public record, and you've got a lot of homes that are a lot of deeds that are quit claims due to divorce, and they're $10 exchanges of real property, which is not a fair value. And you have some that are arm's length, where parents are selling homes to their children for pennies on the dollar, and those aren't fair value either. And then, of course, the most common example from the past housing cycle is a foreclosure or a short sale, where we do provide a foreclosure estimate for foreclosures, but uh, the Zestimate itself is designed to tell you what that home would transact for as a non-distressed piece of inventory in the open market, which means that we've got to be really diligent about identifying foreclosure transactions and filtering those out, so that the model is not downwardly biased and becomes really a blend between a non-distressed and a distressed property. So that's one area that we kind of have to watch for quite a bit.
And we have a question from Twitter. I'm glad this one went through. I'm having trouble getting my tweets out there. And this is an interesting one from Fred McClymans, who asks, he's wondering how much the Zestimate use case, how much has the Zestimate help define rather than just reflect real estate value? So what impact has Zillow itself had on the market that you're looking at?
Yeah, that's a question we get a lot, and particularly as our traffic has grown, is people want to know, are you reflecting the marketplace? Are you driving the marketplace? And my answer to that is that on any given, our models are trained such that half the errors will be positive and half will be negative, meaning that on any given day, half of homes are going to transact above the estimate value, half are going to transact below, which I think reflects the fact of what we've said since launching this estimate, which is that we want this to be a starting point for a conversation about home values. It's not an ending point. There was a reason that the name Zestimate came from the internal working name of a Zillow estimate. We got tired of calling it a Zillow estimate, so we started to call it a Zestimate. And then when it came time to ship the product, we're like, why don't we just call it that? But it was called the Zillow estimate, Zestimate, not Zaprice, because it is an estimate, and it's meant to be a starting point for a conversation about value, and that conversation ultimately needs to involve other opinions of value, including real estate professionals like an agent or broker or an appraiser, people who have expert insight in the local area and have actually seen the inside of the home and can compare that inside and the home itself to other comparable homes. Um, so um, uh, that's kind of it's designed to be a starting point. And I think that the fact that half of homes sell above those estimate, half below, I think reflects the fact that people are. I think it's a very influential data point, and hopefully it's useful to people. But it's not the only data point that people are using, because another way to think about that stat I just gave you is that on any given day, half of sellers sell their homes for less than this estimate, and half of buyers buy a home for more than this estimate. So clearly, they're looking at something else other than this estimate, although hopefully it's been helpful to them at some point in that process.
Mm-hmm. And we have another question from Twitter. And again, I'm glad this one went through. It's an interesting question. Have you thought about taking data such as Airbnb data, for example, to reflect or to talk about, analyze the earning potential of a house?
That is an interesting. I'm noodling on that. We've done some partnerships with Airbnb on economic research, kind of understanding the impact of Airbnb, combining it with housing data that we have. We do a lot of work on that. I think probably the direct answer to that using Airbnb data is no. But when you say the earning potential, I guess what I'm hearing is the potential to buy that home and convert it into a cash flow positive rental property, and things like what's the cap rate or the capitalization rate or the price to rent ratio. And that we do um, we do a lot of, because we have uh, the the largest rental marketplace in the U.S. as well. So we have a ton of rental listings, and we use those rental listings for a variety of purposes. Among them being to help understand price to rent ratios, and what we compute is called a break even horizon, which is how long do you have to live in a house to make buying it more worthwhile than renting it. So and I guess the other thing that would directly help that question would be the fact that on any on any home page, on any page that lists a home, we call them internally a home details page. On any homes page on Zillow, we show both the estimates of what we think that home would sell for, and we also show a rent estimate, what we think it would rent for. And that hopefully allows the homeowner to have some notion for, they would decide to rent it out, what they could get for it. Now, the question I think from your from Twitter is an interesting nuance, which is our rental estimate is on the rent of that entire home. What if you just want to rent out a room or a part of that home? What's your potential on that? And that is a very interesting question, which we thought some about. We don't have a product to directly, a cool product there that seems directly related to the question would be an estimate on Zillow that would tell you if you did want to rent out a room or two in that house, what could you fetch? And that's a very interesting feature. Duly noted.
Let's go back to, excuse me, to the discussion of machine learning. Machine learning has become one of the great buzzwords of our time, but you've been working with enormous data sets for many years now. And when did you start? Did you start using machine learning right from the start? We spoke about a little bit about this earlier, but how have your techniques become more sophisticated over time?
Yeah, I would say yes. I've been involved in machine learning for a while. From, I guess, I started in academia when I was a researcher in the university setting, and then at Expedia was very heavily involved in machine learning, and then here. So there's been the biggest change in, well, it's hard to parse it. I was going to say the biggest change has really been in the tech stack over that period of time. But I shouldn't minimize the change in the actual algorithms themselves, over those years, where uh, algorithmically, you've seen the evolution from, um, at Expedia personalization. We worked more on things, relatively, uh, you know, sophisticated but more statistical and parametric models for doing recommendations. Things like um, uh, uh, unconditional probability, item to item correlations. Um, and now most of your recommender systems are using things like collaborative filtering, or algorithms that are optimized more for high volume data and streaming data. Um, uh, and then in a predictive context, we've moved from things like decision trees and support vector machines to now forest of trees, although simpler trees, but much larger numbers of them, and then more exotic uh, mashups of those algorithms, decision trees that have in their leaf nodes regression components, which are very helpful in some context. But in terms of the tech stack, it's been transformed. Back in the day, you were doing stuff with C code. If you were using, maybe you were doing prototyping in R, maybe S plus. You were usually coding in Fortran or C, but you were doing it all from scratch. On a single machine and trying to get as much as you could into memory. And today that from that it has gone through to more proprietary systems. Maybe you were using SAS at scale, to then you were maybe using a database, maybe MySQL, to you using Hadoop, and then today, generally, you know, our firm and other firms that are on the cutting edge here are using something like Spark, probably, maybe encoding directly in Scala, or maybe using Spark that's plugging into Python or R. Um, and then generally those frameworks are now running in the cloud, and are using streaming systems like Kinesis or Kafka, real-time triggering of events. And so all of the infrastructure is changed, and I would say for the better. That as a data scientist now, you can get up and start working on a problem on AWS in the cloud, and have an assortment of models to quickly deploy, much easier than you could back 15, 20 years ago, when you were having to code a bunch of stuff, start out in MATLAB and port it to C, and you were doing it all by hand.
Are you looking at are you making predictions about the future value of homes, or only from the past to the present moment?
The Zestimate itself is, what is a, I guess some people would call it a nowcast. So it's a prediction for what the home will sell for today if it were on the market. We do also forecast the Zestimate forward in time. Right now, we project it forward about a year, and that model is a combination of the machine learning models I described before, where it takes the point estimate of what we're estimating today and then moves it forward. It's combining it with a modeling framework, a forecasting framework, which we've developed for the purposes of forecasting our housing index, which is called the Zillow Home Value Index, which tells you basically what home values have done over the past 20 years and what they will do over the next year. That forecasting framework is itself a combination of some straightforward univariate ARIMAs and some more complex structural models that are taking as inputs economic variables and trying to predict what those economic variables are going to do to home prices in your local market over the next year. We take those forecasts on the index and then apply them to the individual level with some nuances, where it's not just a forecast for your area. We then break that forecast down by housing segments, so that maybe high-end homes are going to appreciate more quickly than low-end homes, or vice versa. That nuance affects the forecast that's then applied to the property level to create the forecast for the Zestimate.
I want to remind everybody that we're talking with Stan Humphreys, who is the Chief Analytics Officer and Chief Economist at Zillow. And if you're trying to ask a question by Twitter, just keep trying. And some of those tweets are actually getting through. Stan, what about the data privacy aspects of all of that? Is I know you're aggregating public data, but still you're making public information about the value of people's homes, and isn't there's a privacy aspect to this? So how do you think about that?
Yeah, that's a we've been fortunate in that most of our business operate really almost all of our business operations involve domains that are all a matter of public record. And a lot of the value added that we've done is just bringing that public record data and collating it together into one spot, and uh, and standardizing it such that it's kind of a standard way to look at it, regardless of how they collect data in Idaho versus Florida. We'll standardize it so that on Zillow you're looking at it, or Trulia or StreetEasy or HotPads, you're looking at it all in the same way. Um, but at its core, that's all public record information, which is beneficial when it comes to privacy, because all of that data is at this point generally accessible. It's all available if you were to walk into a county tax assessor's or county recorder's office. And at this point, most of those offices are now online. So if you knew where to look on the web, then you could find that information online, because it is a matter of public record, because of the fact that real estate is the basis for property taxation. And there's a long-standing history for why things involving real property, liens, and actual information about real property is public domain information. But um, in all states, most of that information is public, except there are some states where the actual transaction price itself is not a matter of public record, and those are called non-disclosure states, states like Utah and Texas. But everything else is public record. And what we're doing is then providing estimates and derivative data on top of that. So we're creating housing indices out of that data, or valuations, and those valuations are theoretically no different than if you were to go to the county tax assessor's website or into their office. There's already a market value that the tax assessor is putting on your home, which is a matter of public record. Ours is, we're applying probably a lot more compute power and algorithmic sophistication than a lot of tax assessors are able to do. But it, in principle, is exactly the same concept as that.
Somehow it feels different when that data is aggregated and then presented in such a succinct form, and it's also easily accessible. Somehow it feels different.
Yes, that's true. I would say it feels different. Um, I would say it feels different in a lot of different ways. Uh, for most consumer applications, that it feels different because it feels really good. Um, when for an individual, there are some individuals who would like that information would like all the information. They would like no facts about their home to be public, so they would probably prefer if the county assessor didn't make it public. Um, they would prefer if the transactions were not a matter of public record, and they would prefer if companies weren't able to put derivative products on top of that. I certainly get that. The problem becomes a collective action problem, where individually we would all prefer to take all of our information offline, but collectively we would like the ability to look at other information for us to make better decisions. And collectively, as a society, we have decided that this information should be public. And because of that, companies like Zillow are able to make that information public as well, which we think the consumer benefit far outweighs the individual uh, concern that they would prefer the facts about their homes not to be public. You know, there are also, I think, there are real social equity issues here. There's a lot of research when you look at kind of disclosure and non-disclosure states, for example. You will find that uh, taxation policy is there's been some fantastic academic research on this issue, but property tax, there's more inequality in property tax in non-disclosure states than in disclosure states, because people aren't able to look at those transactions and figure out how does that tax relate to what that home's really worth, and therefore disputes are less likely to occur on the lower half of the price spectrum. But wealthy people will always go to dispute and try to get a lower assessment on their homes, and that leads to um, more inequality in the assessment of tax than would exist otherwise, which we think is a harm to the overall public benefit.
And you just raised some public policy issues. And so we in our last 5 minutes, I'll ask you to put on your economist hat and share your thoughts on how this data economy, in a way, you're right in the middle of the data economy. How do you see that changing the workforce and the public policy issues around that?
Yeah, I think I do I do a lot of writing now on um, policy that's related to real estate and housing, and also some that's just kind of more broader economic discussion. And in that broader economic discussion, I do a lot of a lot of one of the themes I touch on somewhat often is the need for us to um, get ahead of the changes that are coming due to machine learning and the data era, where I think there are two parts of our societal framework that were really established back generally with the last transformation. Well, not the last transformation, probably the one prior to that, where basically we moved from an agrarian society to a manufacturing society. It was around that time that we started, mandatory compulsory public education. And we also started to set up, with the progressive era in the early 1900s, social security systems and unemployment systems that allowed for people who may be thrown out of work from a manufacturing job to have a little bit of a safety net before they found their other job. Um, I am concerned in the current. This is less real estate related and more the impact that machine learning is going to have full bore on our economy, thinking about the impact of driverless cars, for example, on people who drive trucks and cars. That's 5 to 8 million people, and they're going to come under pressure as self-driving car technology becomes more ubiquitous. And I am concerned that one, we need to up our educational game, where we need to think about college education as being the equivalent in the late 1800s of high school education, and we need to be doing a better job of training our college graduates for the jobs that exist. Um, and then I would say that on the unemployment side, that system I described is set up for a world where you lose a job and your next job is likely to be in the same town you're in and in the same field. We're going to go through probably for the next 30 years a lot of unemployment where the job that you need to get is probably not in the area you live in, and it's probably not in the field you live in. It's going to require some retooling, and that's more than 6 weeks to to 3 months of unemployment. We need to think hard about people who are moving from a manufacturing job, and maybe their next job needs to be a computer assisted machine operator, which is a non-trivial job that needs to be trained for, and you're not going to learn it in 4 weeks. So I'm definitely interested in public policy trying to address those issues better.
And in the last 2 minutes, what advice do you have for public policy makers on these topics? You mentioned education as being one thing. Any other thoughts on this?
Yeah, I would just encourage us to. I mean, we seem to be in particularly ideologically charged times. I would encourage us to think broadly. Like we did when we came up with compulsory public education for children, and try to think there are a lot of these ideas that um, if you think about there are a lot of these ideas um, that have been suggested from both the left and the right. And for example, a possible replacement for you know short-term unemployment insurance is something more like a more robust negative income tax, which we have a form of that in this country called an earned income tax credit, where for low wage workers, we supplement their income through the tax system. Um, Milton Friedman was a champion of a very robust negative income tax on the right. We've got a lot of liberal thinkers who have been championing it on the left. That type of system where people could kind of step out of the day-to-day work and be assured they're going to make a base level income for a longer period of time, and that income is going to allow them to get another job. Those ideas have come from the left and the right, and I would hope that we're going to be able to fashion a system that's going to work better for the next 30 years than we've got now, and that we don't get hung up on rigid ideology on it.
Okay, and I'm afraid that about wraps up our show. We have been speaking with Stan Humphreys, who is the Chief Analytics Officer and also Chief Economist of the Zillow Group. And Stan, thank you so much for taking your time and sharing your thoughts with us.
Michael, thanks for the interview. It was, it's a broad range of topics we got to cover, so which is quite unusual, but it's been fun.
Yeah, it's great. 45 minutes is enough time to dive in. Everybody, thank you so much for watching, and go to cxotalk.com/episodes and be sure to subscribe on YouTube, and also like us on Facebook. You should do that. Like us on Facebook as well. Thanks so much, everybody. Have a great day. Bye-bye.